Dobro jutro, Kalimera, Guten Morgen, good morning, and a very warm welcome to DevReach 2018. You all excited to be here? Yes, it's early morning. Let's get the energy going. For those of us who have been planning this for months, it is so good to see all of you. Now, 2018 marks the 10-year anniversary of us hosting DevReach here. And that is a big deal, because if you think about over the years, just how many people have been involved in putting together DevReach, organizers, sponsors, speakers, and all of you. I think we can all be very proud of the developer community that we have built around DevReach. So I think for everybody who has ever attended or participated in any DevReach, let's hear a huge round of applause, right? Yeah, thank you. Now, we're going to try to make the anniversary edition of DevReach an event that you remember. And we have some staggering numbers here. Let's recap. We all have the schedule, but we started with pre-conference days yesterday. We had 3 wonderful workshops, and over these next 2 days, today and tomorrow, everybody combined, we are hosting about 800 people. Each of these 2 mornings, we're going to start with a future-facing technical keynote, and then we break out into sessions. We have about 46 sessions by some of the best speakers from all around the world. And at the end of day 2, when your brains are jam-packed with all this information and this wonderful tech that you want to take back to work and do amazing things, we want to leave you with something inspirational. So there will be a closing keynote that's going to make you feel good about yourself and what else you can achieve in your career going forward. Then we take a break. And we walk 10 minutes that way to Hotel Grammy, where you're going to meet us for the attendee party. And hey, I mean, it's our anniversary, so we got to celebrate. It's going to be a kick-ass celebration. Stefan's going to be there with the band. We'll have a few surprises, and we go home when you want to go home. Deal? We'll have fun. All right, we cannot put together DevReach without a lot of support and love. And here are some wonderful folks: Milestone, Active Trades, Beta Gaming, Smart IT, Bull Pros, and DSK Bank. They are sponsoring. They're helping us out. So I encourage every one of you to go visit them at the booth, which also gets you in line to win wonderful raffle prizes at the end of day 2, okay? Our brains cannot function without coffee and food, so we have some sponsored coffee breaks and lunch breaks. We'll have to keep it a little quick because we have a packed schedule, a lot of good content. We have a history of supporting a social cause here at DevReach, and the Because Foundation is here. Go see them at the booth. You can buy some handmade crafts. You can take a picture and put yourself on a magnet. So please help us out. It all goes towards a good cause. If you would like to share your experience here at DevReach, I encourage you guys to use the DevReach hashtag. We have a Twitter wall outside, so you can see yourself. We are live streaming this to 2 other overflow theaters that are next door, and also to YouTube, which is internal for now, but we will make it live, and everybody can relive the keynotes. If you're between sessions, I encourage you to take a minute to provide us some feedback. We have some phenomenal speakers, but everybody could use some positive feedback. So that's the URL. Between sessions, just tell us really quick how you feel about the content that you see here at DevReach. Now, over the years, what's kind of constant in our tech industry is change. We have seen a lot of evolution, and I think DevReach for the last decade has been a witness to a lot of change. So let's start our morning by taking a look at some of the latest technology trends and what are we doing about it. So I want to bring on our own tech visionary, Todd Anglin, to walk us through. Thank you.
I don't know about visionary, but I'm certainly next. Good morning. Welcome to DevReach again. This is an amazing event. I think I have the privilege and rarity of being one of the few people who's been to almost every DevReach. Not everyone. I missed the first year, but every DevReach since then I've been here. To that end, does anybody remember when the very first DevReach was? Anybody here go to the first DevReach? Ah, cheaters. 2006 was the very first DevReach. And when we talk about change, we talk about how much technology has evolved from 2006 to now. It's sort of hard to wrap our brains around. The things that we were talking about at DevReach then are very different than what we're talking about now in 2018. In fact, the first DevReach was Microsoft Technologies at your DevReach. So that's where our name came from back then. And on the agenda, we had amazing topics like ASP.NET 2.0, ADO.NET 2.0, SharePoint, amazing new technology. It's going to be big, I think. And SQL Server 2005, the hot stuff. So we were really digging into the latest and greatest, which it really was in 2006, when some of us were still probably in high school or earlier. And if you go even further, think about the things we couldn't talk about because they didn't exist in 2006 for a technology conference. ASP.NET MVC, for all the .NET people in the room, we were in the era before anything like MVC and all the other stuff that's now followed since then. The iPhone, Android, we were a year ahead of that, so there's no talk about mobile app development. Of course, the cloud. We are well ahead of the cloud. That's now a dominant topic for an event like this. And shocking to all of us, there was no GitHub. Certainly no Microsoft-owned GitHub. In fact, I remember going to a conference in Austin and seeing a session around this time about GitHub, and I thought, yeah, I think SVN is going to be plenty. We don't need this GitHub thing. So I'm not a luminary. That's my point. So then, over that time, obviously, DevReach evolved. And I had the pleasure of working at Telerik, now Progress. And in that same time, Telerik and Progress were also evolving with these technologies, adding new UI tools for different technology stacks from Microsoft, expanding into mobile as we saw those mobile platforms come out in 2007, 2008, and then eventually into things like the cloud and how we help you as developers continue to be more productive building your apps. In fact, if you're a .NET developer in particular, or a JavaScript developer, there's still tons of amazing value that continues to expand in the Progress Telerik toolset. UI tools for every .NET platform, from the desktop platforms to the web, including ASP.NET Core. If you're doing JavaScript development, Kendo UI, when it was first born, was Kendo UI, and it was for jQuery. You remember jQuery. It was a thing. It is a thing. And now, Kendo UI comes in multiple flavors, including natively created for Angular, for Vue, for React. So no matter what kind of JavaScript development you're doing, Kendo UI is still there to help you get that job done faster. And then NativeScript. So mobile has also been a big challenge, and NativeScript is something I've worked with very closely. I'm very passionate about. How do we help JavaScript developers with a web background, be productive building apps, native apps for iOS and for Android? And NativeScript is an open source project we've been driving for the last 3 or 4 years. At this point, NativeScript's been downloaded over 3.5 million times, and it continues to accelerate in its growth, helping developers build incredible mobile apps and doing it more quickly. But as we look forward, so we've come from 2006 to 2018, and Progress and Telerik have evolved along that time. The tools we've created have evolved, but there are still big changes ahead. Things that we as developers aren't yet prepared to do, or at least to do well. And as Progress, as a company putting on an event like this, we want to bring developers together to talk about these changes, so you can be prepared, so you can understand how your job will be different and how your development lives can be made easier with new kinds of tools. Tools like Progress Convey. And Progress Convey is exactly about helping you tackle things like the cloud. How do you move to the cloud and serverless functions and all the things that can make your life harder? How do you do that more easily using a skill set you already have? Or chat. Everyone talks about chat. We all know what chat is at this point, but as you as a developer, how would you implement this in your apps? From designing the conversational workflows on the back end to putting that conversational UI in all of your different app stacks, whether it's on the web, on mobile, or on the desktop. Progress now has conversational UI that helps you do this with any chatbot, or even helps you build the chatbot itself. And of course, the most visually stunning, AR and VR. Probably looking even more into the future, but we're working now in our labs building some incredible UI tools that will make your lives easier when you're ready to adopt this and help your business take an entirely new look at how they get their work done. So when it's ready, or when it's time for you to implement it, Progress and Telerik will have the tools that you need. So while we may have started in 2006 as Microsoft Technologies at your reach at DevReach, when we come now to 2018, it's certainly something different. This is really the future of app dev at your reach. Over the next 2 days, you're going to see topics and hear from speakers that are going to help you think about where technology is going next, whether that's tomorrow or 2 years from now. But I encourage you to engage with the speakers, engage in the sessions, after the sessions, absorb as much as you can, and I cannot imagine what we're putting on this slide 5, 10 years from now and laughing at what we were talking about today in 2018. So thank you again for coming to DevReach. Thank you to Progress, again, for helping us put this event on, along with our sponsors. I hope you do have a great time here at the event. And now, my commercial speech is over, and I'll turn it over to the main show and over back to our MC. Thank you.
I'm on? Okay. All right. Thank you, Todd. So let's begin this morning with a glimpse into the future. You kind of see AI and machine learning everywhere, but are we doing the right things? Are we doing things that are ethically correct? And I think all of us are kind of looking around to see what's next. What's the next human-computer interaction? What's the next socially acceptable computing platform? And I think we're all looking around. We don't know, but I think we're fortunate here to have somebody who may have seen the future. I don't know about you guys. I'm not 40 yet, but here is a man who's spent 40 years in our tech industry. I'm extremely delighted to welcome Richard Campbell back to DevReach. Now, Richard, you likely know him from all of his podcasts. Those of us who know him personally, we know the kind of photographic memory he has. We know the amount of humanitarian work that he does. He's really a true veteran in our industry. He's a man of many talents with an enchanting story to tell. So, ladies and gentlemen, please welcome Richard Campbell. Thank you, sir.
All right. I usually start this talk off, in fact, I'll start it off with a clip from home. So I live in British Columbia, Canada, West Coast, and this is a camera that sits between my house and my neighbor's place. We call this the Animal Highway. It is a Wednesday morning about 6 a.m., and on Wednesdays is garbage day in my neighborhood. And so we usually have visitors most Wednesday mornings just to check to see, did you put your garbage out early? And you really shouldn't. Now, I'm in Bulgaria. You guys have bears, right? Yeah. You should see when I play this in Australia. Those guys go nuts. They've got poisonous spiders. They don't handle anything this large. But yeah, that's life for me. I wrote my first line of code in 1977, which is not important. The important thing that happened in 1977 was Star Wars. Right? Just have our priorities list. And that was on a TRS-80 Model 1 with 4K of RAM, a cassette tape player, and a version of BASIC not made by Microsoft. It was a tiny BASIC, and it only had 3 error messages. What? How? And sorry. Which I still think is the best error message ever. I mean, what is object not found but sorry? And as Sam mentioned, I do make a bunch of podcasts. Any .NET Rocks listeners in the room? Wow, that's awesome. And .NET Rocks was at the very first DevReach in 2006. Carl and I were here, and I'm going to be doing a couple of panels tomorrow, so if you'd like to see more shows. If you haven't heard the podcast, free to download. We're coming up on episode 1600, so we've done a few. I also make an IT-based podcast called Run As Radio, and we, for a little while, made a show called The Tablet Show. But we were going to talk about AI, and the question is, should we be afraid? I would start with the term, because the term is terrible. Like, that's just not a good term. It seems frightening. It's old, too. First time artificial intelligence was coined is in 1956. Marvin Minsky and a group of scientists pitched the military on how computing would be able to automate a whole bunch of military tasks. They got a huge pile of money and pretty much failed. Didn't really amount to anything. The word artificial intelligence enters the lexicon of most of humanity because of the movie 2001: A Space Odyssey. So we think about it, Arthur C. Clarke actually published that book after the movie. He and Kubrick worked together on the movie. And so our first real thoughts on artificial intelligence come in the form of HAL. And as we know, HAL kills everybody. So no wonder we like artificial intelligence so much. And so yeah, maybe not a good name. After Minsky's efforts in the 50s and early 60s, there was what they called an AI winter. In the 70s, as the microcomputer started to light up, with a new class of AI tech started to appear called the expert systems. And they were very expensive, but they were the same sort of exploration, building decision tree models to try and work your way through almost a 20 questions idea to collect expert information. These machines ran about $70,000 US. They were mostly programmed in Lisp. And after a decade in the 80s of selling them, they'd sold maybe about 7,000, and then they just sort of faded away. Another AI winter occurred. The researchers continued through the 80s, and they started to break into 2 rough categories, depending on the kind of artificial intelligence technology you were interested in. They called them the neats and the scruffies. So the neats were the Minskys of the world that really focused on the mathematical constructs of decision tree modeling and these expert systems. But there was also a group that called the Scruffies that said, no, this is too complicated to do neatly mathematically. What we really should do is try to simulate more human or natural behaviors around that, around AI and machine learning systems. So that's where neural networks ultimately come from. Now, in that, as you get to the 90s, the real breakthrough, which actually was a win for the NEETs, was a thing called Deep Blue. Anybody remember Deep Blue? Beat Kasparov at chess. So IBM threw a huge amount of money in building a really high-end computer that could compute all these variations and ultimately was the best chess player in the world. That's the technology that eventually became Watson, which most people know for winning Jeopardy, very much in the same model. So not the neural net model, but the decision tree model. The decision tree model basically breaking down information into categories so that you can figure things out quickly that way. The voice systems were very interesting this time too. They existed, but the decision tree approach to voice meant a lot of training. You had to repeat patterns to be able to match them to the trees properly. But the neural nets started to really come along in the 80s, and the original models were pretty simple. There were literally only 3 tiers. So you'd have an input layer, a hidden layer, and an output layer. And this is where we were starting to simulate brain behavior. I would present an image to the neural net and then train it by saying, that's an apple. Here's another image, that's an orange, over and over and over again until you eventually get some level of success. The early neural nets in the 80s were not particularly effective. And I have some I've been in the software long enough that I had friends who had their degrees specialized in this particular area. But it was too computationally intensive and ultimately wasn't reliable enough for most people to use in a big scale. But today's AI is really derived from that. This is Geoffrey Hinton. He's one of the scientists that in the 80s was doing neural net experiments. And he proposed a much more complex model, the convoluted AI model or neural network model, that had a mathematical way to redo backpropagation. And so he was looking at neural nets that looked more like this. So you had an input layer, you had many layers of neurons below, and then an output layer on the other side. And there was the backpropagation model allowed you to do corrections in a mathematically efficient way. But in 1986, computationally, this was not viable. It took way too long to run. It was impossible to train. And so that paper pretty much just sat on the shelf until the 2010s. So Hinton was a tenured professor at the University of Toronto, and so he was perfectly happy to continue teaching AI because guy's got a job. But the upcoming AI scientists in the new millennium, they started reading his old stuff, and the real breakthrough comes in 2012. So it was folks working under Hinton that actually entered a contest for doing image recognition. So this contest, the ImageNet contest, started in 2010, largely with decision tree models, and the best system that had been made so far was able to recognize about 75% of the objects. And by the way, this data set that they were using had been manually created, 14 million images where they'd taken images and had identified every object in them. And now they were trying to write software to do the same thing. In 2012, they entered a convoluted network based on Hinton's principles, and a first try got 85% correct. Within 3 years, it would get 100% correct. And this is really what kicked off the new AI revolution, was being able to build these neural nets that were able to do recognition. I like this particular example. That 8, by the way, is from the ImageNet set. It's one of the sort of regular, here's a hand-drawn 8. So you imagine, you just turn it down to black and white, 28 by 28 pixel, map out the numeric values of each of those whites, and so you can sort of see the 8 is hovering in there. And then all those values are plugged into neurons, and over this training models are repeatedly able to figure out what the 8s actually look like. This is how neural nets work today. And you see this breakthrough manifest in 2012 and 2013, mostly with voice recognition systems. A lot of people cared a lot about image recognition at this point. It wasn't that important. But this is when Siri appears, right? Actually made by a third-party company that Apple purchased. And Google Voice appears, and Microsoft has Cortana. What happened? Why did this? What was interesting about these voice systems is there's no training anymore. You could pretty much just talk to them, unless you're Australian. Accents are hard, right? And what really happened was Moore's Law, right? And we're all computer people here, so we know what Moore's Law is, right? I throw up this graph of CPUs from 1970 to 2018, but I have an exponential function on the Y there, right? I'm going up by orders of magnitude. So we get a nice straight line that shows Moore's Law. And Moore was only talking about increasing the number of transistors in a given space on a silicon chip. But it's persisted for 40 years. If I graph this without the exponent on the y, it's kind of a useless graph, because humans have a tough time with exponential functions. Here's how I explain Moore's law to the average mortal. I show him this. Anybody recognize this? Warp drive from the Enterprise? No, that's this. This is a Cray 2 supercomputer, circa 1985. This is the most powerful computer in the world at the time. It was about 16 million US dollars, cooled by mineral oil, consumed 200 kilowatts of power, and it pulled down about 1.9 gigaflops of processing power. There was only a couple of hundred of these ever made. They were mostly in universities. They modeled nuclear explosions with them. And you compare that to the iPad 2, 2011, $800. You can put it in oil once. Battery lasts about 10 hours. Also 1.9 gigaflops of processing power. So 26 years later, what used to be a supercomputer is now something you play Candy Crush on. That's Moore's law, right? And of course, it's continued. It's important to realize this is a 2011 device, right? It's not fast. If we talk about fast, well, in the PC world, I'd look at the 2080 video card. Now, if you're a Bitcoin miner, this is your favorite card in the world, right? It's about $1,000, and it does 13.4 teraflops, or 13,000 gigaflops, so 7,000 times faster than an iPad. And that's just a video card. Like, that's still not fast. I mean, fast today would be top-end supercomputers. So, you know, Cray's great-great-great-great-great-grandson, this is IBM's AC922. That's 122 petaflops for about at 8 megawatts of power. So buy your own power plant to go with your computer. 9,000 times faster than that video card, and about 64 million times faster than an iPad. One of the ways to see the future is to recognize that the future is here, it's just not evenly distributed, right? So the fact that we have computers at this kind of horsepower, and we see that timeline, we're going to keep getting more compute. Now, we do know that Moore's law is going to run out, and for no other reason than we're going to run out of atoms, right? The 10 nanometer process that that Intel is struggling with right now to make chips, you're down to about 45 silicon atoms across per transistor. You only have so many atoms. Quantum effects start to apply. And so that's going to end, but at the same time, there's a lot more compute available to us. But we were talking about artificial intelligence. Here's the best chart I've found to kind of break down all this umbrella term that has become AI. And the lines actually mean something. The length of them shows what's new and what's old. So Minsky's project in the 50s and 60s ended up being this planning, scheduling, and optimization systems for the military. It worked. It just didn't do everything everybody hoped it would. It wasn't the artificial intelligence that people were thinking about. Same with expert systems from the 70s, robotics from the 70s, the original speech systems that existed in the 90s that were only so good. Today, when you talk about the latest generation technology, it's stuff around image recognition and these deep learning models with the neural net. So why has it come true today? Well, I would really look at two forces. Not only just Moore's law and the increased availability of compute, but also the cloud. That by having centralized computing, we have a place to put all these computers that we can share them effectively. And we're seeing companies like NVIDIA start to build hardware specifically for doing neural nets. This is a DGX-1. These things run about $130,000, and they're 170 teraflops. So not like the supercomputer at 122 petaflops, but these are small units, right? You put them together in a block they call a Saturn V, and now you're talking petaflops for about $16 million, like reasonably priced. Still, you wouldn't buy them yourself. You'd use them in the cloud. And so Amazon and Google and Microsoft have huge piles of these. By the way, there are next generation units coming down. And so that $16 million Saturn V array using these DGX2s is down to $4 million. Moore's law still applies. The computing density is continuing to increase. And if you start looking at modern problems we're trying to solve using these kinds of models, like the ultimate neural net example. So Deep Blue's win was a win for the NEETs. Let's talk about a win for the Scruffies, and we'll talk about it in the form of Go. So Go is a Chinese game, 19 by 19 grid, white and black squares, and the total number of game combinations represents more atoms than there is in the universe. There's so many possibilities there. You cannot brute force your way through this one. And so the AlphaGo folks sat down, and starting in 2014, they built a neural net model to be able to program, to teach it to play Go. And had it watching Go games being played and watching the outcomes for about 2 years. So a lot of computational time. By 2016, it was playing at a Go championship level, and in 2017, it beat the best Go player in the world 3 games to none. And an interesting sideline to this is this lit the Chinese government up. Go is a Chinese game, and when the Americans built the best player in the world out of a computer, it started an AI revolution that's happening in China right now, and it's something important to pay attention to. The impact of it's going to be significant. But for us, out in the rest of the world, that was only the beginning. So after making AlphaGo work, they developed AlphaZero. So the Go model was a kind of neural net programming called supervised learning, right? Where I give you finished games of Go with all of the steps, and you can watch how the best players in the world played. That's why it took a couple of years to actually program it. With AlphaZero, they did unsupervised learning. So taking the most modern hardware, the only thing they taught this game to, the only thing they taught it was how to play the game Go. Now play by yourself. And it played by itself for about a month. And after a month, having never seen another game of Go, only ever played by itself based on the rule set, it played AlphaGo and beat it every time. Took a month. So for fun, in a paper they published late last year, they taught it the rules to chess for about 2 hours. They played chess against itself. And then they played it against Stockfish. And Stockfish is now the best software-based chess game in the world. It can beat Deep Blue. It's just a much more modern version of it. And they played 100 games. It was 28 wins for AlphaZero, and the rest were all draws, which is kind of normal in championship-level chess. The important part about that is not that AlphaZero could actually beat chess, but that it used less than 1% of the computing resources that Stockfish used. So the real demonstration was that these new unsupervised neural net models with these new computational GPUs are incredibly efficient. They think they could make a version of AlphaZero that would be the best chess player in the world that would run in your phone off of the GPU in your phone. So it's not esoteric level compute. It is very ordinary level compute in the modern infrastructure that can play at this particular level. Now, the real argument we get when I start talking to folks about this is AGI, or Artificial Generalized Intelligence, versus ASI, Artificial Specialized Intelligence. And so far, I've only shown you ASIs, right? AlphaGo and AlphaZero, they are specialized intelligence. They play games. AGIs are what folks that Elon Musk and the late Stephen Hawking and Bill Gates were talking about over the past few years, about the risk of a generalized intelligence sort of destroying the world, right? And you could spend a lot of time going around in circles on this particular issue. We don't actually know how to make a conscious machine. We're having a tough time defining consciousness for ourselves. Some of us are more conscious than others. And I would argue this: understanding the power of a specialized intelligence, just something as simple as AlphaGo, we are perfectly capable of destroying our civilization with that technology. We do not need artificial generalized intelligence to wreck everything. And I'll show you some examples of that. In fact, if we can't get our heads around the potential of what specialized intelligence can do, we are never going to get to build generalized intelligence. And if we do solve that problem, we'll be able to solve the GI problem as well. We're starting to automate a huge array of work these days, and it's actually been going on a long time. And most of us in this room have been part of that automation in one form or another. It started with very manual things that we put over to robots, right? Car robots, that's a good example of it. Non-routine work's a little trickier. There are smarter robots today. I watched a video clip of a robotic arm being able to pick up pieces of cooked chicken and put it into a bento box, which is an incredibly difficult problem because no two pieces of cooked chicken are the same size. So smart enough to actually handle those shape variations in packed boxes. Where we're finding more people feeling more threatened is when you get away from the manual stuff and into more of the thinking-related work, like customer service work, where we're now starting to build bots that knock down whole classes of customer service work into automation. And then the non-routine work, which is like half of the work in the world, the work of doctors and lawyers and scientists and so forth, that AI tech is starting to encroach on. But all of those implementations have been specialized intelligences, not generalized intelligence. And so I feel the generalized intelligence is literally a distraction. It's to take our eyes off the ball that is the actual issue, which is the tech we have today can do some extraordinary things, and we need to think deeply about this. So let me give you another example. If you watch the videos from Build in 2017, the Microsoft conference, they showed a series of, let's say, speculative technologies. One of them was at a construction site. So this construction site was covered in cameras that were able to keep track of the locations of all of the employees and all of the tools. So at the simplest level, the fact that someone could flip open their phone, pick up their phone, and say, where is Amy? And the system would know Amy is currently in this room. It got more interesting when they started talking about dangerous tools or dangerous behavior around a tool, where a particular operator took a jackhammer and leaned it against a table where it was likely to fall. And the system was able to determine that was a dangerous position and notify the nearest person, there is a tool dangerously placed, you need to go lay it down. And there was another example where a forklift hit a can of oil, tipped it over, and it caused a spill, and it was able to identify the spill, identify the content, notify everyone in the area to move away, and the cleanup crew what it was and where to go to clean it up. So they wrapped it in a very nice wrapper, this continuous observation system, being able to provide safety to people. But it got me right in the gut. It hit the uncanny valley for me. Now the uncanny valley is really a concept around robotics. As long as robotics are cartoonish or mechanical, people don't mind them, they're fine. But as we start to make robots that look more like humans, it dips down below this line that creates a revulsion effect. It's very fundamental to humans to have this reaction to something that's not quite human. If you get it perfect, that's fine. Right? Healthy people, we have positive reactions to that. But when you fall down below that line, you get in trouble. And it was an interesting thought to think, I've just watched a technology demonstration, and I'm a technology guy, and I'm getting that revulsion effect. And it was that sense of privacy, this idea that here we have these cameras, and we're finally mounting to the system. But we're living in a camera-saturated world. They're everywhere. They're on all our phones. If you're wearing a Google Glass, then yeah, there's one on your head. But every filling station has a few cameras in it. Every grocery store has a few cameras in it. You hear all the time on the news when there's been a crime that they go around and collect that video. And the idea that between the internet and the cloud, we could integrate all those cameras together with a smart system that would continuously monitor that behavior, it's fairly frightening. It can be even apocalyptic. And so it got me thinking, when's the last time we were dealing with an apocalypse? And what did those guys have to say about it? So let me pull up two people from the past. Enrico Fermi, who was the inventor of the original atomic bomb, and his contemporary Edward Teller, who built the, quote, hydrogen bomb, or the multi-staged bomb. Enrico Fermi said, it is no good to try and stop knowledge from going forward. Ignorance is never better than knowledge. The question he'd been asked that made him say that thing was, should we put the genie back in the bottle? After the Americans had successfully developed the atomic bomb, and they were starting to get their heads around how destructive this force was, and this was before they'd even built the big one, should we go back? And he's like, no, there is no way back. Knowledge is knowledge. We have to go forward. We have to learn to deal with this technology. Edward Teller said an even more profound thing, and he built the more powerful bomb ultimately. He said the extinction of the human race will come from its inability to understand the exponential function, or to emotionally comprehend that exponential function. And we all in this room have been living that exponential function, that Moore's law effect, that every year we get more and more compute, we can do more and more, and we're hitting this crescendo now with deep learning models and our ability to simulate and create remarkable behaviors that we have to decide if we comprehend this exponential function and what we're going to do with it. And I started feeling a little Orwellian about the whole thing. And so I wanted to throw up a cover of 1984. There's a lot of covers to 1984. I found like 60 of them. It says a lot about a book that they keep making editions of this book. Orwell had an interesting insight. It's 2018. It's many years after 1984. He wrote it in 1948. He was predicting the surveillance state in a lot of respects. And now I stand in front of you knowing I have the tools to make this come true. We just have to choose. What are we going to do with it? Now we're seeing pieces of it, not even using the tools with the potential of a state like this. Things like the whole fake news movement. What's real, what isn't? If you want to look at an AI manifestation of that, watch this.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time.
So this is an AI technology that takes multiple images and videos of Obama and synthesizes them together so that Jordan Peele was able to sit there, impersonate his voice, and it would model those words against Obama. Pretty good. I mean, if you really study that video, you'll see flaws in it. But it's compelling. It is powerful that we can now not trust video. Recently, a Belgian activist group about climate change put out this.
Dear people of Belgium, this is a huge deal. As you know, I had the balls to withdraw from the Paris Climate Agreement, and so should you. Because what you guys are doing right now in Belgium is actually worse. You agreed, but you're not taking any measures. Only blah, 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 bing, bang. Than before the agreement. Shame. Total shame. At least I'm a fair person. People love me because I'm a fair person. I'm the fair. Just like this video.
It's right in the video, and everybody believed it. Like the chaos around it. This was a group trying to advocate for Belgium doing more about climate change, so they made this thing, and they had to sort of like, it's a fake, and not a very good one, and yet it was still good enough. So this is what we're up against, that a group of climate change folks can generate a poor quality video. So what does that look like going forward? The major players in the AI space, and you also see they're mostly the cloud vendors, the Amazons and the Googles and the Microsofts and the Facebooks, IBM, are all creating groups around how are we going to create some kind of compliance standards for ASIs, right? When you think, I mean, how much longer before that deepfake technology I just showed you, which was brand new a year ago, is a Snapchat filter? We know how this works. It's going to become trivial to make video. The most likely thing we're going to be able to do to fight against those videos is that we'll use another ASI to analyze it and tell you whether it's real or not. Right? Then it's an arms race. We create worse and worse technology against better and better checkers of that technology. The expectation is that these players will ultimately become gatekeepers. Because we'll be operating most of this through the public cloud, potentially we can create filters on this. But this is today. We're facing this problem right now. And the next year will be very interesting. And we haven't even addressed the whole scope of issues. The training models that create most of these neural net systems are based on data that we've generated from various sources. Social media is a huge player in this. The sheer amount of video, photos, and text that we've pumped onto the internet for our own amusement, one degree or another, have become the libraries that we build these deep learning models from. And they represent our biases as well. So if you build a deep learning model to make policing more efficient, and you go back through all the policing behaviors of the past, the deep learning models are going to amplify the biases that exist in those. And this becomes a self-fulfilling prophecy, especially when you wrap technology around it. You've had the experience when you write a piece of software that helps people make determinations that they tend to defer to the computer. The computer says this must be right. Actually challenging that, is it right or not? That's not an easy thing to do. And it's going to get worse when we start thinking about the biases that are in our data sets. So you see that if you go into an area with a police force expecting to find crime, they will find crimes. Whether or not they're substantial or important or common is a separate question. And those biases end up showing up in the data. And so now these days we have groups that are specializing around managing the bias in data. All data is going to have bias in it. It's kind of inevitable. The question is, do we recognize what those biases are, and do they help us inform decisions we make based on the data? This ethical conversation is not that strange from an engineering perspective. If you have a degree in civil or chemical or electrical engineering, part of your education was an ethics conversation. The people who build bridges, chemical processing plants, and electrical infrastructure, they have an ethical obligation to society about the dangers that they produce in their technology, and that they have to say something about that. I think one of the challenges we have in software is we're struggling to be a profession. There isn't really the concept of a software engineer. But should we get to a place where we recognize software as an engineering discipline, again, ethics will be part of that conversation. It needs to be. And so for us as so-called amateurs, or as the people that exist today who understand and are going to be able to take advantage of this technology, I think it's important for us to study the ethics of this. Know that moral compass inside of you of what are you prepared to do with this technology? Because we know it can go badly off the rails. Microsoft created a chatbot called Tay. And they did not give Tay any concept of a moral center. And it did not take very long for the internet to give Tay an interesting moral center. And they took Tay offline within a day with a few apologies. Another issue in the deep learning model is that it is opaque. I can show it a picture of a cat, and it will tell me it's a picture of a cat, but it won't tell me why it thinks it's a picture of a cat. Now that's fine if it gets it right. It's not fine when it gets it wrong. And so now we're up against, well, why does it get it wrong? So DARPA, the American research group for the military, is trying to develop this concept of explainable AI. So actually decomposing the deep learning models into the elements so they can see what was the decision-making process that arrived at that. I'm not particularly wild about the American military developing this technology in one way or another. And you're actually seeing this happen throughout the United States right now, where the group of Google AI folks refused to work on a Department of Defense project, created quite a fuss around it. We've seen similar things out of Microsoft. So you're seeing these experienced developers now wearing their ethics on their sleeve. We can talk about the right way to do that, but it's becoming apparent that these are routine conversations. One of the largest applications of deep learning model we're going to see is mobility as a service, which, just to remind everyone, comes from DARPA. The DARPA Grand Challenge was back in 2005. So it's been 13 years since they spent that money to build these first automated vehicles and spent tremendous amounts of money. Those LiDAR sensors on the roof there, made by a company called SICK, they're $30,000 a piece in 2005. But Moore's Law applies, and today those same sensors are about the size of a deck of cards and $500. So Enrique Fermi is right. We only get to go forward on this. We've moved a long way in the technology of it, and we're just working on the AI models. You may have seen in the news in the past couple of years, there's been a whole bunch of conversations, what they call the streetcar dilemma. There's a runaway streetcar coming down the rails, and you have access to a switch, and it's headed towards 3 people crossing the road. But if you throw that switch, it'll veer off and only hit one person. Do you do it? What if the one person is a baby in a carriage? And you just play with all of these different options. And if you read the overall story of the streetcar dilemma, it comes down to this concept called agency, that generally humans when making a moral consideration like that, choose not to touch the switch. Because the moment I touch the switch, I'm part of the decision-making process. And I'd rather not be. Now, why is that relevant when we start talking about automated driving? Well, we are going to put a sense of morality into that software. The fact that the software could rapidly make the decision to minimize the number of people being hit. Is it something we should do? Should it do an extraordinary thing? And remind us all that it's automation rather than limited the same way a human's limited. These are conversations going on right now. The Watson people have poured a lot of energy into AI in medicine. The area where you're seeing interesting results is specifically around image recognition. So the ability to study huge numbers of MRI scans and PET scans and so forth to pick up on cancer diagnoses, to be more effective than the average human at recognizing all of those things. It's very much a decision tree type model, but you're seeing different systems implemented. If you talk about sort of high levels of automation, like how much do you want a human to do medicine on you versus a machine doing medicine? Anybody ever had the LASIK process done? Where they modify your eyes? Have you seen that? Okay. Did you really want a person doing that? They use a machine, they lock your head down pretty tightly and pin your eyes open so you get to watch. And they cut the top of your cornea off, fire a laser into what's left to change the shape, and put it back on again. You probably want a machine to do that because precision is important. You want to get it right on. So what we're seeing with medicine, and what I think we're going to see with AI as a whole, is this combination service, that there are going to be better tools for informing our professionals of the possibilities of the different options. Have you considered? And I don't see it as an either-or option. I see it as this is yet another tool. You know, once upon a time we just banged the sticks together, then we threw them at each other. You know, then we hunted with them. We learned to make fire. We've been made these tools. This is the next tool. And this tool will help inform us to be better doctors. Could it work in education as well? You know, there's a strong push to person-to-person education. But we've seen how well children interact with screens, for better or worse. Could the software be a better testing platform so that we can utilize our teachers more effectively on the folks that need the most help directly? I think a combination there has potential as well. So there's a lot of powerful capabilities here that we can improve our society with, but also a fair bit of threat. Ultimately, the decision comes down to us. You have to figure out where you sit on this, because it's coming. It's going to affect the way we build software one way or the other, where your moral center lives on this particular thing, what the ethical model looks like before we develop these things for our own organizations. Just ask that question, because we're going to live side by side with a remarkable set of technology. And I think it's actually a normal part of the progress of civilization. We're just confronted with it. Is it going to eliminate more jobs than it creates? If it does, it will be an unprecedented incident. Because every other time that we've advanced technology substantially, yes, we've eliminated classes of jobs, we've also made more. Maybe this is the time that that will change. I find it interesting to see software developers feeling threatened by automation now. After all this time of us automating stuff, now you're worried about your job. But I don't buy it, actually. I think they are merely amplifiers for us, that we can do more. As long as we do it right, do it well. Have a great rest of the conference. Thank you so much for your time.
All right, thank you so much, Richard. That's it with the general sessions this morning. Quick coffee break, and then we go into our breakouts. And like Richard said, enjoy the rest of DevReach, and thanks for joining us.